Hi, welcome to a Physionic detailed study analysis. Today we're going to be going over a whole host of different studies. I suppose I have 8 studies here. I've pulled together as many of the studies that I could on the topic of nattokinase, however you pronounce it, nattokinase, and heart disease. So we're going to find out the effect that nattokinases have on potentially preventing and potentially reversing atherosclerosis, as well as other metrics of heart disease. So, if that's what you're here to find out, then we will be getting into a deep dive of all the details, including the data and the mechanisms. If you're not familiar with who I am, my name is Nicholas Verhoeven. I'm a PhD candidate in molecular medicine. I hold my master's in exercise physiology. I've been in a lab for 10 years, and this is what I do. I translate studies, I aggregate all the studies together, I show you the data, and then we can come to our own conclusion. So you can either agree with my conclusion at the end of this video, or you can disagree based on the data that I present. That said, if you want to skip the entire video and you want to skip to the overall conclusions, then there's a conclusion section, so you can skip to that. But as always with these detailed analyses, you're going to be missing out on a lot of context. So I cover the high level, but there's a lot of stuff that you're going to miss. So if you're one of those people that's going to be joining me for this entire journey, then buckle up. Let's get into this. All right, so the topics that we're going to be discussing, first off, we're going to be getting into the mechanisms of action as we normally do. Then we're going to go into the effect that nattokinases have on blood lipids, so like blood cholesterol, triglycerides, things like that, as well as blood glucose. And then we're also going to be going over nattokinases for blood pressure. And then if you're a Physionic insider, I'm going to be going over the atherosclerosis reversal aspect, as well as blood clotting, so which is kind of the most common way that nattokinases are considered. And then I found this really interesting study on post-heart disease recovery and the effect that nattokinases might have on there, as well as more optimal dosing. So there's a few different dosing strategies that studies have used. So I'll go into more detail on that. So if you're interested in accessing the full version of this, then just hop on over to the Physionic Insiders and you'll get access to this plus a whole host of basically all my other content. So certainly welcome to join there. I'd love to have you. Okay, so that said, let's go into the mechanisms of action. So as always, for each one of these studies, I'll have a document with those studies laid out, as well as the funding sources, so more details on the funding sources. And additionally, I also have amendments. So after this video publishes, sometimes there are a few corrections that I need to make. So you can see those pinned to this video, but as well as more specifics are listed in this document. So certainly look that up. So we're going to start out with this nattokinase supplementation cardiovascular risk factors. It's displayed as study 269. So anytime you look for study 269, this is what's going to pop up. And it's a systematic review and meta-analysis that released relatively recently. There's no funding and no conflicts of interest with the authors. We're also going to be relying on study 276, which is this one right here. And this is a public funding. Again, more details for funding sources, like is it NIH funding? Is it the American Heart Associate? Like whatever it might be, that's going to be found in that document. Beyond that, however, we're first going to look at what they talk about in terms of the mechanisms of action, so we can actually understand what nattokinases are and what they actually do. I feel like I'm going to be changing my pronunciation of nattokinases. Nattokinases. I never know how to pronounce it, so please excuse that. Okay, so let's understand what nattokinases do and what they, just generally their mechanisms of action that have been proposed so far. There's a lot more research that needs to come out on this topic, but based on what we know so far, which is based on the 2 studies that I just referenced, so 276 and 269, I believe. So nattokinases are actually completely a non-fitting name for what it actually is. If you're into molecular biology or cell biology, then you'll understand that a kinase is an enzyme that actually adds a phosphate group to another molecule, another protein. So it specifically adds a tag. What's funny about this is that this is not a kinase, and yet for some reason it's called a nattokinase. And it's typically found in a substance that's usually found in Asian countries, specifically Japan, called natto or natto. Again, I'm probably butchering the name, and you're going to see me waffle back and forth, but we're talking about the same thing. And this protein has a number of effects that occur in the body, and exactly what those effects are. So if we were to look over here, we have our red blood cells that are going through our blood vessels. So we've got the top of the blood vessel, we've got the bottom of the blood vessel. Think of the blood vessel being cut in half so that we can see inside. We've got our endothelial cells here. This is a single line of cells that are part of what's known as the endothelium. And they regulate our blood pressure, they regulate our inflammatory state, they regulate a whole bunch of things related to our vasculature and our blood vessels as a whole. Then we've got the subendothelium here. And when we have plaque formation, we tend to have this plaque starts to build up in the subendothelium. So they get past these endothelial cells and end up getting stuck in the subendothelium, so sub being under, and then start to create this plaque, which ultimately leads to an occlusion in this blood vessel. So if we were to zoom into one of these endothelial cells, we'd find that nattokinase would be present there, especially if you're going to be supplementing with it. So it has a whole host of different effects, as you can see, and there may be more than what I'm going to be describing here, but these are kind of the main mechanisms that have been detailed. So for one, when we think of clotting, which I guess I'll be getting to in just a little bit, we've got this clotting cascade. I'm actually going to show you an image of what the clotting cascade looks like. It's incredibly complex, like factor 3 affects factor 8. Factor 8 has a role against factor 10, but can inhibit. It's just like so much stuff going on. And it's incredibly complex, but there are some enzymes that are also involved in this clotting cascade. So at the end of the clotting cascade, you have a clot. You have the grouping of platelets and red blood cells grouped together with this protein called fibrin. And I'm going to show you an image. As a matter of fact, I'll show it to you right now. So it looks like this, just so that we're clear on what this actually looks like. We've got the red blood cells. Here we've got our blood vessel. Again, we're looking at a cut so that we can see through it. We've got our red blood cells. We've got the platelets that are activated, and we've got this stringy protein all around it called fibrin. And this fibrin protein allows for the clot to actually stick together. So plasminogen is a protein. So this specific protein, we're not talking about this protein. This is the inhibitor of plasminogen, but plasminogen is a protein that goes through and actually degrades this fibrin. So it breaks up clots. Now you can imagine, obviously, if you have a clot forming and it's not supposed to be forming, which tends to happen with plaque formation. So another independent risk factor for heart disease is as plaque forms, we start to get the exposure of collagen, which is typically found in the subendothelium. And if that gets exposed to the lumen here, this open area of the blood vessel, then you get the recruitment of these platelets. And then you get this whole cascade, the whole clotting cascade that I'll show you an image of in just a little bit, which ultimately leads to the aberrant or the unwanted generation of these clots. So if you can degrade this fibrin, then you can essentially degrade the clot. So the clot doesn't then float downstream and get embedded into a smaller vessel. So a smaller vessel that has less space than this, ultimately leading the clot to then get lodged there and then stopping blood flow downstream, which is called ischemia. So plasminogen inhibitor inhibits this protein called plasminogen that would normally degrade fibrin and therefore degrade the clot. So clearly we want less of this fibrinogen inhibitor to be present. And it just so happens that nattokinase has an impact on reducing the levels of plasminogen inhibitor that's produced by the endothelial cells. Exactly how, I don't know. To be honest with you, I don't know if it's some sort of gene regulation. I don't know if it's some sort of mRNA stability. I don't know if it's a direct impact, like a direct effect of nattokinase on this plasminogen inhibitor protein, where it interacts with it and blocks it. I don't know. As far as from a reading that I looked over, there was no specific details on all that. That's why I mentioned that, a little bit earlier on, that we need a lot more data on the exact mechanisms and just the overall impact that nattokinase has. But we're going to do our best up to the literature that we have up to date. So it inhibits the production of this inhibitor. So that's great. That means that plasminogen, the one that actually degrades fibrin and degrades the clot, is then going to be more active, or could potentially be more active. The other thing is that it inhibits the production of pro-inflammatory cytokines. So pro-inflammatory cytokines are these proteins or these molecules that get released out of the cells. And then these proteins will then recruit more immune cells. So those immune cells will then bind to the cytokines through these different cytokine receptors, and it'll change the immune cell to become more pro-inflammatory. So it'll get recruited to the endothelial cells, which inflammation, especially focal inflammation, is another risk factor for heart disease. So this leads to greater invasion of, let me go over here, greater invasion of the immune cells. So the immune cells will float down here, kind of like these red blood cells, but the immune cells are much bigger and will then invade past the endothelial cells and will then find themselves and kind of get stuck in the subendothelium, assuming that there is sufficient plaque buildup that's also present there. So cytokines, nattokinase reduces the cytokine level and therefore has an anti-inflammatory effect. The other thing that it does is that it can reduce the uptake of oxidized LDL. So LDL is low density lipoproteins. These are particles that contain cholesterol and triglycerides, so fat molecules. And these have been known, I've covered this extensively in other content across a multitude of other studies, that these have been known to move from the lumen here, from the bloodstream, as they're carrying these different components, cholesterol and triglycerides, to the different tissues of the body. If they are overabundant, however, what can happen is that they can either move through a paracellular route, which means that they move between the endothelial cells and end up in the subendothelium and then get stuck there. They get retained by glycoproteins and proteoglycans specifically. So a specific type of protein structure that's there will attract these LDL particles, especially if they're too abundant. So it can happen through a paracellular route, which is again between the two endothelial cells, or it can happen through a transcellular route, which means that the endothelial cell will take the LDL particle out of circulation and will move it from this membrane here, which is called the apical membrane, and then will move it to so that would be the apical membrane right here. We'll move it then to the basal membrane, which is down here, and essentially spit it out. So it will be taken up here, and instead of being degraded, will move across the cell and be spit out the back end without any significant alterations. Now, this is done through particular receptors, so what are known as LOX receptors, so LOX receptors, that are specific to oxidized LDL, although we also have regular LDL receptors as well. But the damaging type of LDL that's been known is this oxidized LDL. So this oxidized LDL can then transfer from the lumen, that blood flow area, to the subendothelium and get stuck there, and then could potentially get further oxidized. So nattokinase interrupts this process. Again, the details of exactly how that happens, I don't know, and there's insufficient research to be sure of exactly how it does it. We just know that it happens because of some of the research that's been done. We need more mechanistic research to be exactly clear. So those are three mechanisms. And the fourth mechanism I'll mention here is that nattokinase can also encourage the production of tissue plasminogen activator. Remember, plasminogen is that protein that degrades the fibrin off the clot. And if we have an activator of that, that means that you have more activity potentially of plasminogen. So you do not want to reduce this one. You want to reduce the inhibitor of plasminogen. You want to have more of the activator of plasminogen, therefore reducing the overall burden of this clot formation through increased plasminogen activity. And again, nattokinase encourages that. So another thing that it does is it actually, nattokinase can directly degrade the clot itself, which is pretty fantastic. It's pretty incredible. So it's like a cleavage enzyme in that it can bind to fibrin and break up fibrin itself, which is pretty incredible. So it does something pretty similar to what plasminogen does, and it can act on fibrin itself. So it also, not only does it have indirect effects by encouraging more plasminogen, it also has direct effects on the clot. At least this is all based on mechanistic information. So we're going to see if that actually truly has an impact on cardiovascular disease in a little bit. Okay, here's the clotting cascade. So as I mentioned, think of all these. I don't have an image of like the proteins themselves, but think of each one of these as a protein. Look at the complexity of that. You've got an intrinsic pathway and you've got an extrinsic pathway, and then they essentially end up combining into what's known as the common pathway. So here we've got fibrin clot formation all the way down here. Look at the number of reactions that have to happen that include calcium and include a number of other factors, well, a bunch of factors that ultimately lead to the formation of this right here, this clot, which is this fibrin over here, allowing for that clot formation. So nattokinase directly inhibits certain reactions here to stop this from occurring. So before this even happens, we also have nattokinase interacting and causing issues. So not only does it affect it after the clot formation has formed, but also the actual clot formation process. Now, this is, to be clear, this is not something that you want to mess with to any huge degree. You can maybe change it within a particular gray zone, but you don't want to completely inhibit clot formation, because then you would have, like conditions like hemophilia, where if you have, for example, an extrinsic, like a trauma, like you were to cut yourself, then your body is essentially incapable of clotting and stopping that bleeding. So a really mild cut could suddenly become pretty life-threatening. So you clearly want the clotting cascade to work. You just don't want it to be overactive, especially when you're talking about cardiovascular disease, which, as I mentioned, when you have some of these proteins from the endothelials that poke out because the endothelial cell is disrupted, then you have this clotting cascade that can occur. Okay, so those were the mechanisms by which that we know so far. There's more details that need to be figured out, but this is what we know so far. So now let's go into nattokinase on blood lipids and glucose. So what exactly is the effect of nattokinase on blood lipids and glucose? So we're going to return back to this meta-analysis that I mentioned. This is of randomized controlled trials, and they ended up looking at, I've got my notes over here, they ended up looking at a number of studies. It was a comparison of 6 studies looking at nattokinase supplementation versus placebo. So that is the ideal scenario, but it's not very many studies. And I did end up opening most of these studies individually. Some of them I could not access, and some of them, I believe, for the atherosclerosis later on, I noticed that they were in Chinese, which I do speak other languages, but Chinese is not one of them. So, and I tried to use AI to try to translate it, did not work. So, unfortunately, one or two of them I couldn't access, not necessarily in this section, but there were maybe one I could not access in this section. And then later on for the atherosclerosis, if you're going to be continuing with the insider version of this video, or if you're watching the insider version of this video, there's 1 or 2 atherosclerosis studies that I could not open because, well, I could open them, but I couldn't read them. So just as a side note. Anyway, So they ended up screening a whole bunch of different studies. They found a bunch of studies that followed. In particular, they used the word nattokinase, so therefore they were included in the initial like grouping of studies. And then they do go through with a fine-tooth comb, and they end up eliminating any studies that might be animal experiments. They might be protocol studies, as in they're not actual data studies. They just talk about, hey, you could try this protocol and it could be a good experiment. Cohort studies, like associative studies, like all that kind of stuff. They didn't purify nattokinase specifically. Maybe they use soybeans or they use something else that contains nattokinase or natto. Review studies, single dose studies. So these had to be randomized controlled trials. And that's how they ended up with only 6 studies after eliminating hundreds of other studies that didn't fit any of these criteria. Here we've got a risk of bias assessment. So with a lot of meta-analyses, you want to do almost all of them, or any proper one is going to have some level of risk of bias assessment. There's a grade assessment, GRADE, grade assessment. You've got a Cochrane review assessment, and then there's a few others as well, but those are the main ones. I think they're quite closely linked anyway. But ultimately, it's a set number of questions. They're standardized questions that the researchers have to answer related to all the research that they ended up aggregating. So we've got the 6 or 7 studies here, and then we've got either they get determined based off these set criteria that they have to fill out. Are they low risk of bias, which is the best scenario? Are they high risk of bias, or is it unclear or unrevealed risk of bias? So you typically want these. If a study is L across the board, that's really good. That means it's low risk of bias. That's the best possible scenario. I believe the Cochrane review has a little bit more granularity in that, but this is pretty standard as well, at least at the time of this recording. And we can see that all of them are low risk of bias, except there's a few here in under blinding of outcome assessment. So looking at the blinding protocol, you want to know if the study, so the study would, in a randomized control trial, typically you would have a study where one group is given nattokinase, the other group is given a control substance, a placebo substance, what's supposed to be an inert substance, and they don't know. See, that's the thing. That's the blinding aspect. So do they know if they're taking nattokinase, or do they know if they're taking placebo? And at the assessment, so is the assessment also blinded, as in, are the researchers aware of which condition a person is in? So there's some that's unknown here, which isn't ideal, and you've got a few others over here as well. So overall, not perfect, but I've certainly seen worse than this. Okay. Now, I'm going to walk you through this one time. I'm not going to walk you through it every single time that we go through some of these graphs. Yeah, I'm going to walk you through this one time. So please refer to this instruction to read all the further graphs that we'll be going over. So this is called a forest plot. And here we've got the study, and for this instance, let me be 100% clear here. Yeah, for this instance, we're looking at cholesterol levels. So total cholesterol levels, just so we're clear. We've got the studies on the left side. So you're seeing Wu et al. And Yu et al. 2009, 2019. That gives you a little bit of detail on, let me go back here real quick. These studies right here, Yu et al. And Wu et al. And then you've got the actual numbers, the results that were seen in each one of these studies. So the mean, or the average result, was 232.3 and 233.8 for the experimental, which means this is the nattokinase condition. Experimental is nattokinase. Control is then the placebo, or most likely a placebo, but could be just a regular control, as in they don't get anything. The ideal would be a placebo condition. So the mean under control is for the control condition. And then we've got the standard deviation, which is the overall variance of the data. So some people had, so the average was 232. So some people may have had 240. Some people may have had 215, et cetera, et cetera. And again, we're measuring total cholesterol here. And that's the same for standard deviation under control. Then we've got the number of participants in each study. So 15 under the nattokinase condition and 14 under the control condition. And this one has 37 under the experimental nattokinase and 39 under the control. Then we look over here, we looked at the overall difference. This is the difference between the mean here and the mean here, calculated out or estimated out, and that gives you the overall difference between the control versus nattokinase is 3.36 roughly. And here we've got 5.3 as the difference. Here we've got the confidence intervals. So while the statistics are going to spit out a rough estimate of where the true result is, the true result may actually fall anywhere between minus 9.37, so a decrease in cholesterol, that's how we would interpret that, or an increase of cholesterol of 16.09. And that's why we see that reflected here. So the 3.36 is reflected right here with this teeny tiny green dot or square. It's probably a square. And then the certainty of the evidence, the confidence interval, is all the way at minus 9.37, which is just shy of 10 here, or all the way up to 16.09, which is down here somewhere. So there's a lot of uncertainty in the data. That's what I'm saying here. On the other hand, with the U study, there's a lot more certainty in the data. There's the green box here, which is indicating this 5.3, and it falls anywhere, but the true result is probably anywhere between 3.75 and 6.85. So that's why the line of confidence is pretty tight. And in terms of, I guess I'll quick cover the weight of the study. The weight of the study indicates the amount of impact that this study, Wu et al., has a weight of 0.4%. The amount of impact that this study has on the overall effect, and really I should put it down here, the overall effect. And that is generally determined by the number of participants that are included in the study, as well as the overall confidence interval, so the certainty of the study, but generally the size of the study. So the bigger the study, the more participants included in the study, then the larger, first of all, the larger this green box is, but the larger the weight is. So that means that this result has more impact on the overall interpretation of this data. That's what I'm saying. And then finally, I'll just quick mention the black diamond here is the combination of both of these studies together. So instead of looking at each study individually, which you certainly can do, one other way to do things is by looking at the black diamond, which will give you an average of both of these. Now, it's closer, it's very much the same as this study. Why? Because this study controls 24.5% weight, and this one only has 0.4% weight. So if you average those two together, it's going to be massively slanted in favor of this study because it has so much more certainty and it's a larger study in general. So heterogeneity can be measured by a chi-squared test. It can be, these are what are known as degrees of freedom. You have a p-value, which indicates the statistical significance of the heterogeneity. So essentially, if anything is below 0.05, it would indicate it is statistically significant. And what we see here is that it's not statistically significant. So what is heterogeneity? It's essentially determining how different are these from one another? Is there consistency there, or is there enough of a difference there that we start to experience levels of heterogeneity? So there's differences between the studies. That's essentially what it's saying. And then the test for overall effect is determined by z-test. You don't need to know about the z-test because it feeds into the statistical significance. Statistical significance, again, is set to 0.05. So just keep that in mind. And we can see it is strongly statistically significant, indicating that there is an effect, that this is statistically significant. There is an effect. But as you can see, it favors control. And we can actually see that by the data here. The total cholesterol values are higher for the nattokinase condition versus the control condition. Now, before you spit out your nattokinase, I have a lot to say on this. So we're gonna hold off on that though, because there's a lesson to be learned here, which is incredibly important. Incredibly important. Okay, and it really fires me up because this is the kind of stuff that I absolutely love about data analysis and opening these studies, but I won't go into it right now. So stay tuned. We'll get into it in just a minute. So then they've split things up based on a low dosage and a high dosage. And so in conclusion, the totality of this data is based on 4 studies. So this was only for the low dose that we just went over. You repeat everything I said also applies to the high dose. Obviously, this one is in favor of nattokinase because it moves to the left of this line here, the 0 line. And we can see that it's the only study that moves to the left. Every other study moves in favor of control, indicating that there is an increase in blood cholesterol with nattokinase supplementation. That's the implication. We're gonna get to that though. And most of this analysis, so this is the combination of all 4 studies together, is reflected here for the overall effect. And that's because we have 100% of the weight from 75.1% between these 2 studies and the 24.9% of these 2 studies combined leads to the 100% here. So we can measure that here. Okay, so that all said, this indicates that there is a statistically significant effect, a p-value, this is the correct one, a p-value of 0.0001 certainty that there is likely an effect of nattokinase in increasing total cholesterol. Okay, there are 2 potential issues with this. Well, one massive issue with this, and then there's one potential issue with this. One is, for anybody that knows about meta-analyses statistics, an I-squared of 52% would typically indicate about a moderate level of heterogeneity, which also means that this analysis type, because so you can do a fixed analysis or you can do a random analysis, a random effects model or a fixed effects model. I'm not going to go into the comparison between those two. It depends. It has an impact on how you weight or how much impact each study has. I'll just leave it at that. And usually with heterogeneity, you want this to be a random effects model. So I think you could argue that they didn't use a random effects model here because the test for heterogeneity did not reach statistical significance. But with 52% on what's known as a Higgins test, a heterogeneity model, you could argue that they used the improper test here to do this analysis. Let's just put that aside for a moment and let's just assume they did the right thing, which again, I could absolutely see an argument for they did the right thing. So that's why I'm saying it's potentially wrong. Okay. However, the one thing I do feel they did get wrong is that they looked at the end result of the study. This is improper. The reason why we see these increases in cholesterol is because they're comparing the end result at the end of the WU study, the end result of the end of the U study, the end result of the HOTUS study, the end result of the Yang study, and they're not considering the delta. That is incredibly important. So what do I mean by that? You need to know this is the beginning of the study. This is the end of the study. So there's time that elapsed here, right? There's 8 weeks, let's say 12 weeks, a year, whatever it ends up being. All these studies are going to be different lengths of time. And what they're doing is they're only taking this measure at the end of the study and saying, okay, we compare this end measure against the placebo's end measure, right? So they're at the same time. So they would be measuring the nattokinase condition versus the placebo. Now that's kind of okay generally, but it's very context dependent, because really what you should be doing is looking at the comparison of the baseline versus the end result and looking at the difference that occurred over that time. The reason why that's important is because if the placebo, think of like where my fingers are is the amount of total cholesterol that they start with. So here, the placebo condition started with this amount of cholesterol. The nattokinase condition started with this amount of cholesterol. And then at the end, let's say nothing changes, then the conclusion is that the nattokinase caused higher cholesterol. but that's because they started at higher cholesterol. You understand what I'm saying here? That is incredibly important because it changes the entire interpretation of this entire analysis going forward for all the rest of the information I'll be getting into. Now, that doesn't necessarily mean that there is going to be a false conclusion that is made from this data, but it could if you're not extremely careful about how you go about the analysis. And I feel extremely confident that looking at the delta there would have been far better than looking at just the end result, because it doesn't tell you about the actual change that occurred. And I will prove it to you when we open some of these studies, because I'll go ahead and spoil it here. There is not an increase in total cholesterol with nattokinase supplementation, because if you look at the deltas, well, we'll get to that. But once you look at the deltas, suddenly everything becomes clear. So let's go ahead and move on with this. So the conclusion based off this meta-analysis is that there is an increase in total cholesterol with nattokinase supplementation. And I will show you otherwise in just a little bit. This is looking at, I believe, low density lipoprotein. Oh no, this was high density lipoprotein. So again, I'm not going to walk you through everything again. You have your education. So now we're going to fly through this. So in general, we see that there's a test for overall effect, and we see that it favors the control. So they changed it now, so that there is a higher level in the control versus the nattokinase condition. And that's true for the low. And for the high, it's actually not statistically significant. You see this diamond is massive, and that's because there's a lot of uncertainty. The confidence intervals are all over the place, minus 2.51 all the way up to 12.79. So one could argue that maybe there is an effect in favor of nattokinase at a higher dose, but for lower doses, there's a negative effect, as in really that the control or not taking nattokinase would lead to higher HDL. Okay, but if you combine both of them together, that leads to basically no effect. So the test for overall effect is 0.72. That does not reach that 0.05 cutoff that we talked about. So the conclusion here is that nattokinase is not beneficial for HDL. We're going to touch on that again. That's, like I said, there's problems with this. The next one is to cover low density lipoprotein. So this one up here that I went on this long thing about, that was total cholesterol. Now we're talking about low density lipoprotein cholesterol, which I briefly touched on during the mechanism section as well. We see that there is an effect, and it's in favor of control. Shocker that there's a better effect or a lower LDL cholesterol with the control compared to the nattokinase, implicating nattokinase has higher LDL cholesterol. High dosage, it's about nothing, so there's no effect. And then when we combine the two, test for overall effect, there's no effect, but it maybe trends towards being in favor of the control. The next one is, I believe, blood sugar. Nope, triglycerides. Excuse me, those triglycerides. We see triglycerides here. We've got 3 studies included, and there's roughly no effect. It's about even across the board, even with this really big study here, or this powerful study that contains 96.5% of the weight of the analysis. There's no effect. And then here, let's see here. Yeah, here we're looking at blood glucose levels. And here we see that there's actually, that it favors control, again, that you have higher blood sugar in the nattokinase condition. Again, hold your horses. Don't get upset if you're taking nattokinase already. We're gonna dive into that with more specificity. But as it stands, this is what the analysis indicates across 2 studies. Okay. Now, let's go into study 274. Let me pull my notes up here real quick. All right, so study 274, we're going to go over, so this is unknown funding. I couldn't find the funding source for this, just to be clear. And here are the details on the study design. We've got nattokinase over here. They had one group, nattokinase. They had one group that was taking a true placebo. Then they had 30 participants. 30 participants, age 53, men and women included in this analysis. They were overweight and they were slightly mild hyperlipidemia, meaning that they had high cholesterol, maybe high triglycerides, but not outrageously high, but just a little bit elevated. This was randomized. It was placebo-controlled, as we see, and it's double-blind, so neither researchers or the participants knew which condition that they were in. It was 2 months of treatment, and it was parallel design, as we see nattokinase versus the placebo here. Okay, let's look at baseline characteristics. Remember, this is incredibly important that the baseline characteristics are roughly the same at the beginning of the study, because any differences at the end of the study, you need to attribute it to the intervention here being nattokinase. If the baseline characteristics are not the same at the beginning, then it makes things a lot more difficult to interpret in terms of the actual effect, down the road. So here we go. We've got 15 people. As I mentioned, there's 30 people in the study, 15 people in nattokinase, 15 people in the placebo. If I can go back real quick. This is the WU study. Let me go back here. WU study right here, this same study. So we're diving in, as I mentioned. Okay, so as we see, you've got triglycerides, cholesterol. As I mentioned, cholesterol, they had high cholesterol. LDL-C is definitely elevated, but there are no differences between the groups. Here it approaches statistical significance. That's set. You could make an argument that's pretty important, because the nattokinase condition had more women, 73%, and the placebo had far fewer women, 33% of these 15 individuals. So I guess that's like 5 individuals were women. And in this one, it was closer to like 10, 11, 12 women that were in this analysis. So that could skew the results. So it's not statistically significant, but it's probably pretty sizable, the actual absolute difference. But overall, across the board for everything else, nothing else was different. If you're looking at like blood sugar levels, blood pressure levels, we'll get to that as well later on, BMI or overall weight, age, roughly the same, nitrogen levels, creatinine. There's all kinds of different measures here, but ultimately the point is that there are no differences across the board. Okay, so let's look at cholesterol. Now we actually get to see the delta that I'm talking about. We actually see what happens over time. So at the beginning, there's no statistically significant effect. There's no difference between the two. So nattokinase is diamond, and the black is the placebo. These lines coming out either end is the standard error of the mean, most likely. I suppose it could be standard deviation, but I think it is standard error of the mean, which is very similar to the confidence intervals that I was talking about earlier. Yeah, I believe it's standard error of the mean. And essentially it gives you the certainty of the data. So this is the best guess, and then the certainty of the data, it's actually could be somewhere in these lines. So no difference at the beginning in total cholesterol levels. Then there's no differences after 4 weeks, and then there's no differences at week 8. Notice something, though, that when we looked, remember, this is the WU study, and we see that, it's not statistically significant, so therefore the correct conclusion here is there's no difference between the two conditions. However, you can see that the nattokinase starts up here and it ends up down here. Now, if you'll allow me, let me go back here real quick to total cholesterol that we talked about. Here's the WU study, and it shows there's an increase in cholesterol with nattokinase. So now you're getting an idea of what I mean. What they're actually showing here is they're just looking at the end results, the actual numerical end results, and coming to these conclusions, which is not actually what is represented statistically in these studies. So we don't actually see an effect here, or like an increase in total cholesterol. There's no effect on total cholesterol by nattokinase or by placebo. Then looking at LDL-C, same story, no differences across the board. HDL-C, remember I mentioned HDL was in favor for placebo for the control condition. We do not see that here. So This is a study that was included and showed worse results with nattokinase because they only looked at the comparison at the end here, as opposed to looking at the comparison before versus after and making that delta difference of let's compare this versus this and this versus this and see where we land. And they would have found that there's roughly no difference, as opposed to implicating nattokinase as increasing cholesterol, LDL-C, or HDL-C. So hopefully that's clear to you. Here are the actual numbers. They've got different values here. So it's not milligrams per deciliter, I don't think. I think it's probably by millimole. Anyway, the point is that it would translate over. So triglycerides, so we also looked at that. I believe that there was no difference on triglycerides. Here they're looking, oh, I'm sorry, they're actually showing the delta here. So this is the baseline to week 4, there's an increase of 3.48 in triglycerides. Here we've got an increase of 7.21. It's not statistically significant across the board, and you can do that for each week across the board. But in totality, and yes, like for example, the nattokinase condition, you see minus 10.845. So you think, oh yeah, maybe there is a reduction in HDL, but there's also a slight reduction in the placebo, and it's not statistically significant. One could argue it's maybe not powered for that. For those statistics nerds out there, you could easily argue that. But as it stands, the data indicates there's no difference between the two conditions. There's nothing positive about nattokinase, but there's also nothing negative about nattokinase. Okay, now let's go look study 276, which is the U study, which was also paired with Wu study, because I was having a little fun when I was saying Wu, U. So the two studies that were the lower doses, we saw that there were worse results with nattokinase. Let's find out if that also holds true for the U study. Here we're looking at a study that's only in women. Let me open up my notes here real quick to make sure that everything is good. Okay, 76 participants. So this one was the higher weighted study because it had more than double the number of participants, but it was only in women, age 53, normal weight, and also suffered from mild moderate hyperlipidemia. Randomized placebo-driven, double-blind, 8-week treatment. So same as the other study, nattokinase versus placebo in a parallel design. Cool. Here are the baseline results and the follow-up. So 8 weeks later. So that's how we read this. Age, there are no differences. So you're looking for p-value differences over here to be able to compare. And let me actually open this real quick. So, okay. The PA comparison here to walk you through this, PA is baseline versus baseline. So for each one of these conditions, just compare baseline versus baseline. And again, we don't want there to be any differences here, and that's what we find. Zero, none of them are below 0.05. This one slightly approaches that. It's slightly elevated glucose in the nattokinase version versus placebo. But the PB is the comparison of follow-up versus follow-up. So this one, follow-up versus follow-up, and we see there's no differences across the board here as well. Now, there are some stars here, so some asterisks to identify there is a difference between baseline and follow-up for the placebo group. So we don't see any changes for the nattokinase group. We do see some changes for the placebo group. So a slight reduction in total cholesterol and a slight reduction in LDL cholesterol for the placebo group. It's not major, but it's a little bit, and it's enough to indicate a statistically significant difference. But the comparison between treatments, between nattokinase versus placebo, there's no difference. Now, let's go back to what we were talking about earlier. Remember, this study also indicated there was an elevated level of blood glucose, total cholesterol, LDL cholesterol. And what do we find? Well, when we look at those, let's see, total cholesterol was 228.5 versus 233.8. Did this actually meaningfully increase? Well, the answer is technically no, because we don't see any statistically significant effects. So the true interpretation should have been no effect, not that there was an increase in total cholesterol. What about LDL cholesterol? There's a slight reduction in the placebo, but there's really no change in the nattokinase. That's the appropriate conclusion there. One could argue that nattokinase prevented cholesterol from dropping, but if we compare it to the baseline, there's no difference there. Or blood glucose levels. If we look at glucose levels, it's, technically didn't change for the placebo group and technically didn't change for the nattokinase group. But their conclusion was because this number is lower than this number, that there was that it pushed the data against nattokinase. That's why it's important to compare the delta. To be 100% clear again on this, that would be 92.5 minus 92.1. That would be a minus 0.4 for nattokinase, a drop. And if you saw that on the forest plot, it would then shift towards the left in favor of nattokinase. For this one, it would be 89.9 minus 91.5, or technically I should say 91.5 minus 89.9, which would indicate what, like a 1.6, something like that, but it would be against placebo. Now you have 0.4 in favor of nattokinase and 1.6 or something like that against placebo. That would then create greater distance between the two and would be in favor of nattokinase. But the analysis didn't do that. It only looked at the end results. That's my point. That's a big, big factor. Okay. Next, we're going to go over to study 275. Let me open this up. Now, to be clear, I had to get a kind of a pre-proof print of this. Pre-proof print, say that 10 times fast. So there's going to be a little bit of writing over the data, just to be clear. I can't do anything about that. It is nonprofit funding, however. This was 265 participants. This was a much larger study, men and women, 65 years of age. They were overweight, and the one factor is that they had elevated LDL cholesterol, at least by that measure. And it was only slightly elevated. We've got nattokinase versus placebo, and this is 3 years of treatment, randomized, placebo, and double blind. Okay, so as I said, there's some writing here. Here we've got the baseline results. Some of this is probably going to be important. Some of it is not. So like low density lipoprotein levels, they don't actually run statistics on this. So we're just going to be using our eye, which can be deceptive on the actual differences between these groups. I would argue most likely that there are no differences between some of the more important ones, like low LDL levels, HDL levels, triglycerides, maybe blood pressure, clearly not 120/72 for both of them exactly. So body mass index, it's a difference of 0.3, things like that you'd want to look over. But overall, generally, there's no glaring big differences between the two groups. Quick check, I got this. Yeah, 65 years of age up here. Then looking at this. So here we're looking at the different measures. Again, we're looking at total cholesterol, LDL, HDL, triglycerides, glucose, and they measure insulin here, and HbA1c, which is the long-term marker of blood glucose levels and the overall cross-linking of sugar with hemoglobin within your red blood cells. And we find here, and here we've got the number of participants that were included in each analysis. This is for a little bit later in the video, went for the insider version. So I wouldn't worry about this right now. This is the number of participants essentially, or the number of visits that came in. That's what I should say. So placebo versus nattokinase, we can look at the numbers. Here again, we see that where they got the total cholesterol values from, right? It's a little bit higher at the end of the 3 years with the nattokinase condition, but again, the values when they started, what was total 207 to 205, there's 207 stayed the same for placebo, and 205 it went up 5 points, which is like within the margin of error. So it probably didn't really change. So, but the conclusion for the previous meta-analysis was that there was, again, an increase. So I'm just pointing this out. I'm going to stop mentioning it though, but it's just really, really important, and it gets me geeked out. Okay, so what we see here is that statistically significant, there's no differences across the board. So none of these changed. So for blood glucose levels, there were no changes. For LDL levels, HDL levels, nothing changed across the board. Then looking at study 272, I could not find the funding, but these were conflicts of interest. So I believe these were researchers that were of industry, if I remember correctly, or they had some ties to industry. So you can look up the details when you look at the form that I've got for you that you can download. So there's some methodological issues with this study. So 1,000 participants, which is really a huge number of participants. That's fantastic. It's 12 months treatment, but then they did some follow-up research after that. Men and women were included, age of 67 years old, overweight. These people were dyslipidemic and had known atherosclerosis, like moderate levels of atherosclerosis, and they were only put on nattokinase. So we don't actually have a comparator to compare against. So there's definitely the possibility of a placebo effect here. Okay, so what do they find here? So they had atherosclerosis data on 683 individuals, and they had a complete lipid profile on 1,062. So we're going to be focusing on this. Here we've got the baseline values. So again, we're not actually comparing against a placebo. So, but still, like these are the baseline values. We see that again, the age. We've got roughly even, slightly more women than men, but roughly even. And then they break things up a little bit based off of like step count, which is pretty important. Like how physically active are these people? Most people were more physically active than 5,000 steps. Another thing is here that I find intriguing is that most of these people were largely not overweight. I mean, the overweight cutoff is 24.9, but I'm sure that if they did the cutoff by 24.9, it might bring a few more people in here, like maybe 150 people in this group. But for the most part, it's probably that most people were not overweight by BMI standards, which of course is flawed, but that's the best we've got. The other thing is alcohol drinking. They usually consumed less than 100 milliliters per week. They had some people, some confounding variables here is that some people were taking vitamin K2 as well. Some people were taking aspirin. All of them were hyperlipidemic, as I mentioned before. And then 683 individuals that were actually tested had known atherosclerosis. So I believe all these people had atherosclerosis, but the ones that they actually did follow-up testing on, they only had 683. Now, this is a confounding variable here, which is unfortunate, but it's also a low number of participants that make up this total 1,000. So it's only about 20% of people that make up that are confounded. Now it's difficult to tease that information out and see, well, did that 20% drive all the results that we're about to see? Or if we don't see a result, is it because these people, not enough people were supplementing with K2, for example? Now, they do a little bit of that sub-analysis in this study, but it's still, I don't think that they have enough individuals to really tease those differences out. Okay, so here we've got triglycerides, total cholesterol, LDL cholesterol, HDL cholesterol, and lo and behold, interestingly enough, with 1 year nattokinase supplementation, there's a drop in triglycerides, total cholesterol, LDL cholesterol, and HDL cholesterol, or then there's an increase in HDL cholesterol. So, and that's, pretty sizable, about 15% up to about 20%. So 15 to 20%. So what's going on here, right? All the other studies that we looked at did not show an effect. I can go and tell you that the dosing here was higher than most of the other studies. So that's a possibility that dosing may be a factor here. The other thing is, though, however, that there's no placebo group here, which is a huge confounding variable. They need to have a placebo group to be certain of these results. So I realize that some people, like I've seen some people comment like the placebo effect isn't real, which is just like insane. There's so much data on this, and I've shown it many, 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 many times across all kinds of different studies. As a matter of fact, we saw it in this analysis. One of the previous studies showed a drop in total cholesterol and LDL cholesterol with placebo consumption, but they don't see that with nattokinase. I mean, that's another example of a potential placebo effect. Anyway, I'll get off my pulpit. The point is that here, there's some flaws with this study, but there are also some exceptions with this study, like the dosing and the length of time, except for that one study that did 3 years. And here we see an effect. So it's really difficult to then say, oh, well, I only believe this study. We just need better data. Like they needed to do this study with a placebo group. Point blank, they absolutely needed to do this with a placebo group. Okay, then to separate this out, I also wanted to show some of the data on the differences between male versus female. And we see by separation, because I know that women are also interested in this stuff. And sometimes it's usually the case that it translates to women as well from men, but like there are instances where things don't translate to women, and it's important to create those distinctions. So wherever I can, I try to make sure that to point out those differences. But in this situation, it seems to be consistent. So with men or women, they both experience roughly the same effect size as well. So we overall see these improvements in triglycerides, total cholesterol, LDL cholesterol, and then increases in HDL. Okay, now let's talk about nattokinase on blood pressure. All right, so study 269. Let me pull this data up. This is, again, the meta-analysis. Now, while I've been highly critical of this meta-analysis, this time I think they got it right. Just because the delta didn't make a difference on the interpretation. That's the only reason why, not because they suddenly corrected things. It's just it just worked out both ways. So here they're showing that here we've got this HOTUS study and the U study. We actually opened up both of those studies before. We've got the nattokinase condition, the control condition here. Remember how to read this. Go back to the very first time that I opened up this meta-analysis. I explained what all this data indicates. We see that there's a test for overall effect. It is statistically significant, and it favors control in this scenario. So I guess I should take my words back. They actually got this wrong. And I'll explain why, because we're going to open these studies up as well again. So we see that there's just the slightest decrease in systolic blood pressure. So we're looking at systolic blood pressure here in the control condition versus the mean in the experimental, which is the nattokinase condition. And again, a 0.6 difference when looking at the control versus the nattokinase condition. So this would indicate that there's an increase in systolic blood pressure from nattokinase supplementation. But again, don't get angry. Relax. If you're taking nattokinase, we're going to open these studies up. I'll show you what the truth is. Okay, so let's open up this Jensen study, which is another study looking at blood pressure. I don't think that was one of these studies. So let's look at this study. What study number was that? 270. This was industry funded, so please keep that in mind. Details on the industry funding are in the document. You had 74 participants, men and women, 55 years of age, overweight. These people did have elevated blood pressure. This was a parallel design, 8 weeks long, nattokinase versus placebo. Let's go. Okay, this is the study design. I realize this looks a little confusing. They started out with 221 participants. They recruited 79. Then they had a few people. They had 37 men, 42 women, and they put 19 in the placebo versus 18 taking nattokinase. And remember, this is double blind, so they don't know what they're taking. And then 19 women in the placebo and 23 in the nattokinase. Then they combine these two data sets. So nattokinase men plus women all grouped together, and the placebo versus placebo, or placebo plus placebo, for 38 individuals in the placebo condition. But unfortunately, what happens is they have a few dropouts. So they have one person drop out of the placebo for the women. They have two people drop out of the men. Nobody dropped out of the men for the nattokinase, but and two people dropped out for the nattokinase for women, which ultimately led to 74 subjects that actually completed the study. So, which was a full 8 weeks. All right, let's look at the baseline values. As I've mentioned, we've got 19 women, 19 men, 23 that's for placebo, and then nattokinase is 23 and 18 for men. And we see age age range, it's basically two measures. They're looking at age and BMI, or overall weight. And you could tell that these people are overweight. So they're obese individuals for the most part, and there are no differences across the board. So baseline wise, we don't get a ton of information, but baseline wise, there's no differences. But we do know that they're hypertensive. They do have to have high blood pressure. All right, let's look at the data then. Baseline versus 8 weeks later, placebo is the dotted line and nattokinase is the solid line. And we see, remember, these lines here are the standard error of the mean. So they give you the certainty of the data overall. We see that systolic blood pressure, everybody combined, that there's, I know it looks like it, like placebo may decrease a little bit, nattokinase may decrease a little bit. If I remember correctly, this was not statistically significant. So maybe it's approaching statistical significance, but there's a slight decrease. You could maybe argue there's a slight decrease in systolic blood pressure with nattokinase, but at least by comparison to placebo, there's no effect. One could argue that there's a mild decrease with the nattokinase when you compare baseline versus nattokinase. When you look at diastolic blood pressure, there is an effect of nattokinase where it decreases nattokinase relative to the placebo. Now, that might be because the placebo slightly increases and nattokinase decreases. It's possible that this would have also happened maybe if they'd had more individuals in this study so they could really tease out the differences between the two. I don't know. But as it stands, one of these does indicate a positive effect of nattokinase on blood pressure, which is, again, against what the meta-analysis showed. And that's because, again, they're comparing only the after effects. And keep in mind that this study was not included in the meta-analysis because I think maybe it released afterwards. I could be off on that, but for some reason it wasn't included. Then when you break things up by women and men, interestingly enough, the diastolic blood pressure effect is solely driven by men. Pretty interesting. So this would imply that women would not get a benefit from nattokinase supplementation on their blood pressure, but men would. Now, the effect here is about 4 to 5 points. So it's not massive, but it's still something and can certainly have an effect. Now, keep in mind, these people have hypertension. So does this necessarily apply to people that don't have hypertension? We don't know. But at least we can say there's nothing negative that happens to blood pressure. There's no effect for systolic blood pressure for either. But interesting that the main effect is driven by men and not driven basically at all by women. Okay, let's look at study 271. Here we've got, was this one? It might have been included in the meta-analysis, but don't quote me on that. So here we've got 86 participants, men and women, age 47, overweight, high blood pressure. So same conditions, relatively similar conditions as the last one. 8 weeks of treatment, randomized placebo and double blind. You got placebo versus the nattokinase, and this is parallel design. So comparing nattokinase versus placebo. Here we've got the baseline values. Again, we're just, they don't give us a ton of information. Most of these people were hyperlipidemic, so slightly more, but overall there were no differences between the two conditions. And they were slightly overweight, but it was roughly equal men and women, maybe slightly fewer women in the nattokinase group. Okay, so this is they actually measured nutrition here as well, which I thought was kind of cool. So there are no differences across the board. I'll go ahead and tell you. So this is a balanced diet. They consume carbohydrates, consume proteins, consume fats. If people are going to ask me, well, would this have occurred on a plant-based diet? Would this have occurred on a ketogenic diet? I don't know. And nor does anyone else at this point, because we have 8 studies. We don't have studies getting into those kind of granularities. This is just a balanced diet of consuming carbohydrates, proteins, and fats. They're all on the same diet. So whatever differences might be there, whatever results we might see from this study, are probably diet independent. Now, do you see greater effects or reduced effects on one diet or another? You may. I don't know that. We don't know that. No one knows that at this point. And overall, there were no differences in like dietary cholesterol intake, body weight, things like that. Total energy expenditure. So I guess they measured in total calorie intake. So they looked at their metabolism as well. No effect. So I guess we could say nattokinase had no effect on their metabolism. There's absolutely zero effect. But as far as I know, that's never been reported before. So here we've got confirmation. No effect on metabolism. All right, now let's look at blood pressure. Systolic blood pressure, diastolic blood pressure, and nattokinase is now the one with the dotted line, and control is the solid line. Here we see a comparison at before, so baseline. We see there's no difference between the two. There's no difference in diastolic. You can tell these people have pretty high diastolic blood pressure. Good gracious. And getting into the 90s, that's really high. And systolic blood pressure is pretty high as well. But I've seen this before. I've not seen that high of diastolic blood pressure in quite some time. It's usually like 80 or 85, something like that. Okay, so what we see is that for both conditions, we largely see a decrease in blood pressure. But no, of course, the placebo effect doesn't exist. And yet, somehow this is happening. I'm just taking a little jab. Anyway, the point being here, though, that with nattokinase, you see a greater decrease in blood pressure. And that holds true for the diastolic as well as the systolic blood pressure. So this goes against what the meta-analysis was saying. So now we have two studies that show there's a reduction in blood pressure. Now, keep in mind, the effect size here is not massive. We're just talking about a few points, talking about roughly 5 or fewer millimeters of mercury or points of blood pressure added effect. So just keep that in mind. It's not like you take nattokinase and suddenly your high blood pressure disappears. Not the case at all. But there is a positive effect of nattokinase. So cool. Now, this one was included, I remember. So this is the HOTUS study. This is the 3-year study, if I can remind you. Looking at men and women, had a pretty large sample size, around 200, 300 people, but 3 years long, which is really great. So as I mentioned, there's some writing here because I couldn't get access to the version that didn't have this writing. And here we've got the measures over 3 years. Systolic blood pressure, and we've got measures of placebo in blue, and red is nattokinase. And we see largely that there are no differences across the board. At no point did nattokinase lead to a reduction in blood pressure? Did placebo outperform nattokinase? And same thing with diastolic blood pressure. So the result here is that there's no effect on blood pressure. Now, something I'd like to point out here, these people are not hypertensive. They don't have high blood pressure. So is it possible that nattokinase is only really helpful and effective for people that have higher blood pressure? That's a possibility. So just keep that in mind. But as it stands, this one shows at least no negative effects, unlike what the meta-analysis indicate that there was an increase in blood pressure. That's not the case. Okay, so here we are at the midpoint conclusion. If you're going to be following along with the extended version of this video, just join the Physionic Insiders, where I'll be covering this in terms of nattokinase, reversing arterial plaque. Does it actually have an effect? Optimal dosing for nattokinase, and nattokinese's effects on blood clotting, as well as like post-event, like if you have a stroke or a myocardial infarction or a heart attack, does nattokinase potentially help those individuals? So I'm going to be covering that in the full version. Also, nattokinase, so in conclusion, for this section at least, nattokinase supplementation does not impact cholesterol-containing lipoproteins, nor does it affect blood glucose levels. That goes against the meta-analysis, just to be clear. So I'm disagreeing with what the meta-analysis ended up showing for the reasons that I explained throughout this video. However, it does seem to lower blood pressure. We saw that it has an effect, especially for hypertensive individuals, and it may be specific to people with high blood pressure, but we don't know that. At least there's no negative effect on blood pressure, and there's probably a benefit of nattokinase for blood pressure. These conclusions may be limited by dose and sample size. Remember, some of the studies used, as few as like 15 individuals in each group, as the number of participants included in the studies was few and the dose was low. One poorly controlled study indicates that higher doses may change these conclusions. So that was the study with placebo group. Without a placebo group. So there's no placebo group, which was the weakest study in terms of methodology, but it also showed the greatest effects of nattokinase. So that's kind of interesting. However, and I believe that one was industry funded. So interesting. Just throwing that out there because a lot of people think that, I won't go into it. So just be aware of that. However, what is consistently shown is that at all common doses, there is a reduction in blood pressure. So for that, there's definitely a benefit. So if you're interested in joining the Physionic Insiders, then you can get access to the full version where I'll be continuing to bloviate on about all the science and go into all the intricacies. And you get access to a ton of other stuff, a lot of my other content that I've got out there. But hopefully this was informative. Hopefully you learned something from this, and I'll hope to speak with you in the near future. Have a good one. See ya.